Okay, let's solve this problem one. And the question is soil profile consisting of three layers. This is layer 1, layer 2, layer 3. Layer 1, 2, and 3 in shown below. And question is calculate the values of sigma, which is total stress, U, which is pore water pressure, and sigma prime, which is effective stress at points A, B, and C, D. Point A, B, C, and D, and plot the variations with depth. Okay. Okay. Layer 1 distance is 2.1 meter and layer 2 distance is 3.66 meter and layer 3 has 1.83 meter distance. Okay, for layer A, uh, this zone, this is water level and this is the sign, and so this zone is for dry sand and this is for saturated sand, saturated sand, and this zone is saturated clay. So layer 1 has dry unit weight 1. Dry unit weight equals to 17.23 kilonewton per meter cube, and for layer 2 this has saturated sand zone, so saturated unit weight will 18.96 kilonewton per meter cube. This is given below, and H3 or layer 3, this is saturated clay zone and given value is saturated unit weight is 18.5 kilonewton per meter cube. Okay, let's calculate pore water pressure, total stress, and effective stress at point A, B, C, and D. Okay, okay, this is the given value for point A. For point A, we know total stress equals to distance into unit weight. For point A, there has no distance, so distance is 0, so total stress will 0. Total stress is 0, and this layer is groundwater level, so we know above the groundwater level or in the groundwater level the pore water pressure is 0. So the point A is located in above the groundwater level. So this layer is groundwater. This layer is groundwater level and point A is located in above the groundwater level. So pore water pressure at point A will 0. So pore water pressure will 0 and effective stress is total stress minus pore water pressure, so this will also 0. Okay, okay, let's calculate for point B. Okay, for point B, we know total stress is distance into unit weight, so the distance is h1, which is 2.1, and this is the layer 1, and this zone is dry sand, So unit weight will 17.23. So unit weight will 17.23 and total stress will at point A 36.183 kilonewton per meter square. Okay, let's solve pore water pressure at point B. I already mentioned or said that in groundwater level or above the groundwater level, the pore water pressure is 0. So B is located in groundwater level. So there has no distance. Uh, that's why the pore water pressure is 0. Okay. So pore water pressure is 0, and we know effective stress is total stress minus pore water pressure. So at point P, effective stress will 36.183 kilonewton per meter square. Okay. At point C, the total distance is h1, h2. For h1 distance, the unit weight is 17.23, and for h2 distance, the saturated unit weight is 18.96. So we know the total stress is distance into unit weight plus distance into unit weight, saturated unit weight. As this zone is saturated because this is groundwater level, so this sand is saturated sand. So H1 is 2.1 and dry unit weight is 17.23 and H2 is 3.66 and saturated unit weight is 18.96. Okay, so the at point C, the total stress will 105.58 kilonewton per meter square. Okay, let's solve pore water pressure at point C. Okay, we know pore water pressure equals to distance into water unit weight. So for point C, and this is groundwater table, the distance is H2, which is 3.66 into water unit weight. Okay, 3.66 into this value is fixed for meter, for kilonewton per meter cube, and the value is 9.81 kilonewton per meter cube. Okay, then pore water pressure will 36.904 kilonewton per meter square. Okay, then effective stress will total stress minus pore water pressure. So effective stress will 68.68 kilonewton per meter square. Okay, let's solve this for point D. For point D. For point, this is D and this point is D. For D point, the total distance is H1, H2 and H3. H1 distance, this zone is dry sand. H2 distance, this zone is saturated sand. And H3 distance, this zone is saturated clay zone. Okay, we know total stress is distance into unit weight. Already we solved this two distance into unit weight. H1 into 17.23, H2 into 18.96. We we have only H3 into 18.5 kilonewton per meter cube. Okay, then the total stress for point B will 139.435 kilonewton per meter square. Okay, then let's calculate pore water pressure at point B. This is water level and this is point B. So the distance is for from point from groundwater table to point B. The distance is H2 plus H3. We know the formula is what pore water pressure is distance into water unit weight. So distance is H2 plus H3 and water unit weight is 9.81. So pore water pressure at point B will 53.86 kilonewton per meter square. Okay, then effective stress will total stress minus pore water pressure. So effective stress at point D will 85.58. Okay, our next question is plot the variations with depth. Okay, I just plot the variations. This there is for point, sorry, this layer is for point A, and at point A total stress is 0, pore water pressure is also 0, and then effective stress is 0. And at point B we get total stress is 36.183 and pore water pressure is 0 and effective stress is 36.183. So at point B total stress is 36.183, pore water pressure is 0, this is 0, and effective stress is 36.183, and gradually this is point C point has total stress is 105.58, pore water pressure is 36.904, and effective stress is 68.68, and at point D total stress, this is pore water pressure and this is effective stress. I just draw a line through this point and this is the variations with depth. Okay, thanks for watching my video.